The views and opinions of findings and/or devices discussed in this podcast are those of the host, subject matter experts, and/or guests. Facts represented constitute our understanding as of the time of the podcast, whereas updated factual information may be developed. They should not be construed as pronouncing an official Department of Defense position, policy, decision, or endorsement. Hi, welcome to Clinical Updates in Brain Injury Science Today, or CUBIST, a podcast for healthcare providers about current research on traumatic brain injury, also known as TBI. This program is produced by the TBI Center of Excellence, or TBI COE. I'm your host today, Amanda Gano. Today I'll be speaking with Dr. Donald Marion, a neurosurgeon and TBI subject matter expert at TBI COE. Don and I will discuss a study entitled Associations of MRI-Derived Glymphatic System Impairment with Global White Matter Damage and Cognitive Impairment in Mild Traumatic Brain Injury, a DTI-ALPS study by Dianne Zhu Yang and colleagues and published in the Journal of Magnetic Resonance Imaging in June of 2023. All right. Hi, Don. So the first question I have about this study is, what exactly is the glymphatic system?
Hi, Amanda. Yeah, that's a great question. And in fact, the glymphatic system was first described just about 10 years ago, or in 2012, as a glial-dependent waste clearance pathway in the brain in place of lymphatic vessels. So the brain doesn't have lymphatic vessels. And this system is what drains away soluble waste proteins such as amyloid, tau, and other metabolic byproducts. Amanda, you recall that amyloid is a prominent biomarker of Alzheimer's disease, and tau is a prominent biomarker in the brain tissue of those with chronic traumatic encephalopathy. So they're important proteins. The glymphatic network serves as a front end for waste clearance and is connected downstream to an authentic lymphatic network associated with the dura mater, as well as cranial nerves and large vessels at the skull exits. The anatomical and functional interconnections between these two networks are not completely understood, but it is thought that cerebrospinal fluid flows into brain tissue through arterial perivascular spaces, interacts with the brain interstitial fluid, and flows out of the brain tissue through venous perivascular spaces, removing brain waste, i.e. amyloid and tau protein, into meningeal lymphatic vessels. Amanda, previous studies have found glymphatic system impairment in Alzheimer's disease and Parkinson's disease. And again, it is noteworthy that both of these neurodegenerative diseases are associated with the abnormal accumulation of amyloid and tau in the brain tissue. Others have found that the glymphatic system is most active during sleep, suggesting that sleep deprivation may be detrimental. Discovering novel strategies for optimizing and maintaining efficient brain waste clearance may prove to be important for preventing cognitive decline and sustaining healthy aging. I want to emphasize the importance of the arterial and venous perivascular spaces I referred to previously in the brain as principal components of the glymphatic system plumbing, if you will. Those spaces should be able to be imaged with current microimaging technology, namely diffusion tensor imaging.
Wow, thanks for that, Don. Yeah, so the glymphatic system sounds like it's very important in removing those proteins and possibly for preventing neurodegenerative diseases. Okay, so back to this paper. What were the goals of this study?
Amanda, the investigators wanted to look at the effects of mild traumatic brain injury, also known as concussion, on the glymphatic system. They hypothesized that individuals with mild traumatic brain injury would have an impaired glymphatic system, and that this impairment would also be associated with white matter damage and cognitive impairment.
And how do you think that this study impacts military service members with concussion?
Good question, Amanda, in two important ways. First, service members who have suffered multiple traumatic brain injuries are often concerned about the risk of developing neurodegenerative diseases such as chronic traumatic encephalopathy, Alzheimer's disease, and Parkinson's disease, which are characterized by the accumulation of amyloid and tau proteins. I'm sure in your experience, Amanda, in the clinic, you had questions oftentimes from brain-injured service members about later onset of CTE, for example. So a system designed to remove those proteins effectively would be desirable. And the second way, Amanda, is that the glymphatic system is most active during sleep. And again, your experience, I'm sure, has taught you that service members with multiple TBIs often have difficulties with sleep.
Yeah, I agree. I had those experiences all the time, really. Service members were always asking about potential to develop neurodegenerative diseases, in particular CTE. And then, service members are just sort of inherently not the greatest sleepers, especially those that have experienced TBI or concussion. So totally agree with that. All right, Don, so how was this study done?
So, Amanda, a basic assumption of the study was that the integrity of the glymphatic system could be assessed by investigating the perivascular spaces in the brain. The investigators coined the acronym DTI-ALPS, which stands for Diffusion Tensor Imaging Analysis Along the Perivascular Space. 58 adults with mild traumatic brain injury and 34 healthy controls with no TBI history were enrolled. Their definition of MTBI was similar to the Department of Defense's definition, except that patients could have an abnormal CT. So the MTBI cohort was further divided into uncomplicated MTBI, or 32 patients, and complicated or CT-positive MTBI, which were a group of 26 patients. All MTBI patients underwent DTI within 1 month of their injury. All subjects also underwent neuropsychological tests of verbal memory, attention, and executive function.
Yeah, it's important to make that distinction between uncomplicated and complicated mild TBI. So what did they find, Don?
First, it is important to note that the MTBI and control groups were similar in terms of age, sex, and education. As you might expect, Amanda, the MTBI group performed worse on tests of verbal memory, attention, and executive function. In addition, DTI-ALPS was significantly worse for MTBI patients compared to controls, and also for complicated MTBI patients compared to uncomplicated MTBI patients. The same was true for another measure of DTI, the peak width of the skeletonized mean diffusivity, or PSMD. Note that PSMD is a DTI parameter that is widely used to evaluate global white matter changes, particularly in Alzheimer's disease and multiple sclerosis. Using multiple linear regression analyses, they found a particularly strong correlation between DTI-ALPS abnormalities and deficits in verbal memory and forward and backward digit span testing in the MTBI group. They concluded that the glymphatic system was impaired in MTBI as reflected by the DTI-ALPS, and that glymphatic dysfunction may lead to cognitive impairment related to global white matter damage after MTBI.
And Don, was there a difference in the complicated versus uncomplicated mild TBI groups?
Yes, the complicated group had worse parameters than the uncomplicated group.
So what were the limitations of this study?
I think there are three, Amanda. First, this was a relatively small sample size. Given the implications of this study, if their hypothesis is correct, namely that MTBI disrupts the glymphatic system and can thereby lead to Alzheimer's, Parkinson's, or other neurodegenerative diseases, they would need a much larger sample size and the ability to examine and compare groups at several different ages. The second limitation is the link between DTI-ALPS and prolonged elevation of amyloid or tau in the brain. Longitudinal studies are needed to follow that progression. And a third limitation is the lack of information about or focus on the impact of sleep and sleep abnormalities. For nearly a decade, it has been known that the glymphatic system functions most efficiently during sleep. One of the most common symptoms of post-concussion syndrome, especially among service members, is sleep problems. Moreover, operational demands for service members may impact sleep, putting this population at further risk of reduced glymphatic system function.
Yeah, I agree. That would be an important variable to look at in the future. So what would you say are the key takeaways of this study?
Amanda, these investigators found that MTBI, or concussion, can cause damage to the glymphatic system that was correlated with white matter injury and cognitive impairment. Since the glymphatic system functions as a waste cleaning system, an impaired glymphatic system could lead to waste accumulation in the brain tissue. At the very least, the study strongly emphasizes the need to focus on improving sleep quality and duration following a TBI.
Thanks, Don. So that's all the time we have for today. You can stay up to date on future episodes by subscribing to CUBIST on iTunes, SoundCloud, Stitcher, or wherever you listen to podcasts, where you can also find links to the articles we discuss and other relevant resources. CUBIST is produced and edited by Vinnie White and was hosted today by me, Amanda Gano. It is a product of the Traumatic Brain Injury Center of Excellence, a branch of the Research Support Division under the Research and Engineering Directorate of the Defense Health Agency, led by Branch Chief Captain Scott Coda, Medical Corps, United States Navy. Thank you for listening to this episode.